To demonstrate the use of the multi-threaded update optimization of the Anim blueprint, we will do something a little bit crazy. We will take the first-person character template Anim blueprint and character, and here in the Anim blueprint we will take the update event and we will just repeat it 600 times. And then we will take 100 of those characters and put them in the level. And it means that we will execute 600 updates for 100 characters. In total, we will execute 60,000 updates per frame. And now we will hit play and see how it looks. So you can see we run at about 9.5 frames per second. Super slow and responsive. Can we do something to return, you know, in the green here, to run at some acceptable frame rate? And we can, using the optimization, call it multi-threaded or parallel Anim blueprint update. I already created one Anim blueprint like this, so I will just show you how it works. I will switch the blueprint in the character, compile it. Okay, make sure I have the new one. And now I will hit play. And you can see we are at almost 30 frames per second. And there is a switch global that enables and disables the multi-threaded update. So if I toggle it, you can see we return to our 10 frames per second. And with multi-threaded update, we are at 30. And it's pretty responsive. And if you want to see our CPU utilization, you can see that with multi-threaded update, all our cores are used, because all those updates are run in parallel. And if I toggle it off, you can see that our cores drop it, except the first 4. Well, now we will look at how to implement it. First of all, before I forgot, I will go here and switch it back to our original Anim blueprint, the normal one. Compile. Okay, make sure it's the correct one. To make sure I will run it again. And it's still at 10 because it doesn't support the multi-threaded update. We will now change it to support. Now let's look how to change it. First of all, there is a couple of checkboxes to enable it, and in class settings there is a checkbox use multi-threaded animation update. That is, I think, checked by default. And in the project settings, there is a global checkbox that enables and disables it. Allow multi-threaded animation update in general settings. If you type multi-thread, you will find it. So that is done. Next, what we need to do to run the update on the separate thread. First of all, what is the update of the Anim blueprint? So, as you know, in the Anim blueprint, you have the normal blueprint code, like here in this update event, and mostly the update is this code. And you also have the Anim graph with all those special nodes, and this is another type of code, and it's executed in the second step. So when one frame needs to calculate a pose for a character, first it will run all the blueprint code here and in the anim graph in the active states and the transitions that need to be calculated. And all this is the part of the update step. And once all this calculation is done, we already know all the variables, all the blend weights for all the states and the animations. And we, in second step, we can just take them and calculate them independently from the rest of the code, from the game thread. So now we will, what we are trying to do is to calculate this independently from the game thread, so the game thread can continue to do what it needs to do, and this will be executed on a separate worker thread in parallel. That is because it's called parallel update. And what we will do now, we will first of all get rid of the normal update, because this one cannot be run in parallel. We will take all this, copy it, and create a parallel update function, which is located here. We print thread safe update animation. And we paste our stuff here, and we connect it and compile it, and you see there are compile errors. And error says not thread safe function is valid, is called from thread safe blueprint graph. And same here. Accessing an object reference is not thread safe. So what does exactly those errors means? They means that if we execute this code on a separate thread, it cannot access safely the same memory that the game thread can access. So if we here access the character or character movement component velocity, or call this function, in the same time the game thread tries to access it, we will probably crash the program, because that kind of stuff is not allowed. So what we will do here is to create some other way to access them. And then it's very easy. There are new things like this called property access. So for example, we need the character here. If we click here, we find our character, and we will, as we seen, the isValid is not thread safe. So instead of isValid, we will just check if it's not null, not equal to nothing, and put an if, and then check, get rid of this. And now we're testing it. Compile, and you see no error here anymore. And here you can see this access is thread safe. So the blueprint compiler or Unreal will do will take the value, copy the value of this variable before executing the multi-threaded parallel task, and will give that to the parallel task, and then the parallel task will access this copy instead of accessing the main original value and running in all kind of concurrency problems. So we also will do that here with movement component access, copy this, and then movement component velocity, movement component, we can't resolve. This interface is not very good. Anyway, we will search it like this: velocity, You see you have this in one node instead of this. Check, get rid of it, compile, error is gone. So it will copy the movement component velocity value before executing the parallel task and then use it. And there we have movement component get current acceleration. Same thing, movement component get current acceleration. Tac, read. Oops. I lost it. Here, get current acceleration. And here, movement component is falling. So you can also, you see, use functions. Some of the functions. Movement component is falling. I didn't know that, but you can first connect the accessor to the result. So you find out the type, and then you see it restricts the list, also giving the values and the results of this type. And check, now it's compiling. We can also use this kind of accessor in the anim graph. I don't really know if it's needed, but it's pretty cool. Well, instead of using the variable ground speed like this, you can just go here and say, instead of pin, you can say ground speed. And if you compile it, you see here thread safe, and you get rid of this, etc. Same in the transition. Already did it here actually. Instead of having variable should move, you choose here should move, compile, thread safe. Okay, everything is done, and now we return to our level and we hit play, and you see we are at almost 30 FPS. Without recording it, it's 30, but here we are at 29 and something, and it's responsive again. So now I made a toggle to enable it and disable it globally. It's just a CVAR. I'll show it later. So if I disable it here, check the FPS and the graph, see, path, we're back at 10. And we also can check our threads cores. Now we are on multi-threaded mode, and you see all the cores are occupied. Now if I turn it back, you see only 4 first cores are occupied. All the updates, 60,000 updates, they run together with the game code on the first 4 cores. And here, on the other hand, the updates are distributed on all the available core. So I suppose more cores you have, faster it is, and if you have like 4 cores, probably it's not worth using it. So now, what other consideration I can think of? First of all, well, like I said, it depends a little bit on the hardware. It also depends on how heavy is your anim blueprint. So for example, we added this 6, there it is. We added this 600 loop just because the Mani anim blueprint is so simple that we will actually barely notice any difference if we use just this. But probably normal in real game, the anim blueprint is still a little bit more complicated than this, so it's worth using this. And even if it's simple, it will not be worse than not using it. Implementing the multi-threaded update, it will not make things slower in my experience, so you can always use it, and then just, if your preprint becomes more complicated, then that's good. Another problem with this technique is that it only works with it doesn't work with root motion. If you check here root motion from everything, and this update will be invalid. This optimization will be cancelled, so it will just execute this function on the game thread normally, as you can see here. You see, 7 wars runs at 3 FPS. Completely unusable. So for the root motion, you cannot use it. But for the normal, you can. And that's it. I think I showed everything I wanted to show, and if I find something else about it, I will probably make another video. Thank you very much, and if you want to say something, don't hesitate to comment. Goodbye.